Hello everyone. So here we are with a new topic, that is dynamic or fluctuating stresses. So moving on to the topic. So first is the introduction part, that is load which changes in magnitude or direction or both with respect to time is known as dynamic. So what is a dynamic load? It is the load which changes in magnitude and direction or both with respect to time. So cyclic load and impact load are two types of dynamic loads. In case of static loading, load is gradually applied and remains stable after reaching the maximum value, giving a steady value of stress. But there are a number of machine members which are subjected to cyclic loads, resulting in variable stresses that fluctuate between different levels. Okay, so for example, a particular fiber on the surface of a rotating shaft subjected to bending load undergoes both tension and compression for each revolution of the shaft. Okay, so it was discussed that the failure of members subjected to static load occurs when the induced stress reaches yield strength or ultimate tensile strength. But it has been observed that machine members subjected to repeated or fluctuating stresses often fail at a maximum value of induced stress well below the yield or ultimate tensile strength of the material. Okay, so such failure is known as fatigue failure, as it occurs after a large number of stress cycles. Okay, so what is fatigue failure? I think it is clear now what is fatigue failure and what are the dynamic loads. Okay, so a fatigue failure resembles to a brittle fracture and occurs without any noticeable plastic deformation or necking. Okay, so its sudden occurrence without any noticeable warning makes it dangerous. Okay, so the fracture surfaces are flat and perpendicular to the stress axis. Fatigue failure begins with a microscopic crack that occurs due to some discontinuity, oil holes, keyways, screw threads, etc., surface irregularities due to machining, that is scratches, stump marks, inspection marks, etc., or material defects. This crack propagates due to fluctuating stresses, grows continually, and finally sudden fracture takes place. Okay, so now moving on to the next is the types of cyclic stress. Okay, so a number of different regular and irregular patterns are followed by cyclic stresses in machinery, but generally it follows sinusoidal pattern because of the nature of some rotating machinery. Okay, also for design purpose, only maximum and minimum value of stress is important and not the waveform. Okay, therefore sine wave can be conveniently used to represent any kind of variation of stress between the minimum and maximum values of stress. Following are some important types of cyclic stresses depending upon the level of minimum and maximum stress between which the stress fluctuates. Okay, so here you can see the table where completely reverse stress is extreme values of stress are of equal magnitude and opposite nature with mean equal to 0. Okay, for repeated stress varies from 0 to certain maximum value, that is nature of stress does not change here in repeated stress. In fluctuating stress, minimum value and maximum value of stress is of same nature, that is tensile or compressive. Okay, alternating stress, here stress changes its nature and magnitude of extreme values of tensile and compressive stress is not seen. Okay, so here you can see some of the equations. Okay, so all variable stresses can be considered to be made of two components, that is static component called mean stress and a variable component called stress amplitude. Okay, so mean stress is known as Sm and stress amplitude as Sa. Okay, so here you can see the equation for mean stress is equal to sigma m is equal to sigma x plus sigma max plus sigma mean divided by 2. Okay, stress amplitude is equal to sigma a is equal to sigma max minus sigma mean divided by 2. Stress rings, sigma r is equal to sigma max minus sigma mean. Stress ratio r is equal to sigma max divided by sigma mean. Amplitude ratio a is equal to sigma a divided by sigma m. Okay, so here you can see the figures of three different stresses. That is, first is the figure of completely reversed stress. Okay, so here you can see the amplitudes. Okay, next is the figure for repeated stress. Okay, here stress with respect to time curve has been depicted, and the third is the fluctuating stress, where also the stress with respect to time curve has been depicted with a variable amplitude. Okay, so with this we have come to the end of this lecture. Thank you everyone.